So in the last homework assignment, we talked about just the different equations you might use, talked about free fall and projectiles. Today we're going to get a little more specific, exactly just go through some problems, go through the guess, just to make sure we understand how to do that. So as you look at these equations, these should look familiar. Okay, you find this one on your formula chart right here. Both these are actually on your formula chart, but we will probably use, talk about this one right here whenever we get into projectiles. Really, we can use both of them for projectiles and free fall. Right now, we're going to talk about free fall first. And we'll typically use negative 9.8, but sometimes we'll use a positive 9.8 because we just want to, it doesn't matter the direction. Well, the direction always matters. Let's not say that. But sometimes we want it to go ahead and be a positive 9.8 because we're going to just be dropping it, so the velocity is going to be increasing in the direction it was first going. All right? So we use negative 9.8 or 9.8. So the first example here, okay, we have a punter, and he's going to punt the ball straight up. I've already underlined it in bold straight because that's really, really important for us to understand. All right? With an initial velocity of 10 meters per second, how long will the football take to reach its maximum height? Okay, the maximum height I've already put down here. The final velocity is going to be 0. Okay, we learned that last time. If we have an object that's punted straight up, okay, if it goes straight up at the top, right before it starts coming down, it's going to actually stop, and then it's going to start coming back down. All right, so this just reminds us of that. So the final velocity is going to be 0. The initial velocity, as it says in the problem, is 10, and like we said earlier, our acceleration is gravity, so it's 9.8. So these are all of our givens, and then our unknown we're looking for is time. So from that information, we'll find out our equation is going to be v sub f equals v sub I plus at. So that's your final velocity equals your initial velocity plus the acceleration times the time. All right, so the final velocity we said was going to be 0. It's our substitute step, by the way. Our initial velocity was 10 meters per second plus negative 9.8, because that's going to be gravity, times the t we're looking for. All right? So we want to get 10 on the other side, minus 10, minus 10. So negative 10 equals negative 9.8 times t. So we're going to divide each side by 9.8 to get our answer for t. Pardon me, negative 9.8. So then we end up with an answer of time equals 1.02 seconds. So there's our answer for that problem. All right? As we go to the next problem, I would suggest if you're feeling fairly confident that you go ahead and stop and actually try this one on your own. So once again, go ahead and pause it and try it on your own. We'll talk about it together. Okay, so now we'll go ahead and see how you did. So the time we carry over from the first question was 1.02 seconds. Okay, that's going to be important. That is now a given for this problem. So football is punted straight up in the air with an initial velocity of 10 meters per second. The Jerrytron is 30 meters above the ground where the football hit the screen. So all the givens from the last time carry over. So here's our v sub I, still 10 meters per second. All right, and then once again, we're looking at the v sub f would be 0 because it's going to stop. All right, and we're looking, really we're just looking for the displacement, seeing how high it's going to go. All right, so if it goes under 30, then it would not hit the Jerrytron. And if it goes 30 or above, then it would hit the Jerrytron. All right? So we end up with the equation d equals v sub I t plus 1/2 at squared. All right? So we're going to plug in our time that we found a while ago. So 10 times 1.02 plus 1/2 negative 9.8 times t squared, so that's 1.02 squared. Make sure we do this. This is the part we forget sometimes in our calculator. We forget to put the square in or something like that. So I'm going to bring this down here so hopefully you can see it better than it's on the picture. So in other words, 10.2 plus negative 5.097. So we get an answer of approximately d equals 5.1 meters. All right, so if only going to go 5.1 meters, then no, it would not hit the Jerrytron. All right, so that shows you it. You guys may or may not know this, but this has been hit several times, so they had to be kicking it harder than that to actually hit the Gyrotron. It's actually a pretty good force for a punter to actually be able to hit that big screen up there. All right. All right, I don't know if that was a little glitch there, I guess. So, this slide should look familiar from last night's homework also, or last class period's homework. Once again, just showing you this equation is going to give us the delta x and the delta y. Once again, the reason we use this side for y is because it has acceleration, okay? X, no acceleration. Just thought I'd remind you of that real quick. All right? Let's keep going. So we're going to try this. A ball is thrown horizontally from a height of 1.5 meters. Find the time the ball is in the air. So once again, it's thrown from a height of 1.5. That's the same thing as saying delta y equals 1.5. All right. So delta y we have there. We already know the acceleration of g is going to be negative 9.8 meters per second squared. Those are just some more of our givens. And here we're asking for time, so the unknown is going to be time. It's going to be measured in seconds. So our equation we'd be using there. Once again, I just want to show you how we just did the givens with the problem. So here's a given, and there's a given. Those are all the givens you need. Then we have the unknown. So the equation there would be delta y equals 1/2 gt squared. It's important to realize since delta y, since we're going down, we'd actually put a negative sign on that. So negative 1.5 equals 1/2 negative 9.8 times the time we're looking for squared. Okay? So from that, we can find out the information. So in other words, we could say we'd want to divide this by negative 4.9 because that is half of negative 9.8. So negative 1.5 divided by negative 4.9 is going to give us 0.306, which equals t squared. We have to square root that. Once again, it's another thing we forget. We have to get rid of that square, so we've got to square root that. Once we square root that, we get a time that is equal to 0.55 seconds. All right? So now, once again, we're in the same situation. Now find the horizontal range. The range is the horizontal distance. The horizontal distance is delta x. Once again, we're given height, which is delta y. And we had our initial horizontal velocity, so v sub x is equal to 4 meters per second. And we also want to carry over our time from the last slide. So that would be 0.55 seconds. So then we're looking for our equation. We need an equation that's going to help us find the range. So we got to find an equation with delta x in it. All right, and we have time and velocity in the x direction. So we actually use delta x equals v sub x times t. So v sub x, like we said, is 4, and the time is 0.55. Multiply those together, and we get an answer of delta x equals 2.2 meters. So that is the horizontal range, or how far it would go in the x direction. The next problem we're going to go over something called what I like to call a two-step problem. That means you have to solve for something that is not given to you. Okay? In other words, you have to kind of guess twice almost, okay? Because you have one unknown that you're going to solve for, and once you solve for that, that becomes a known to help you solve the problem. All right, so we're going to, and it's 7:15, just so you know. And we're going to do one together right now. So we have 220 meters, so a rock is thrown off a 220-meter high cliff with a horizontal velocity of 7.2. Once again, I'm doing the givens just by circling them and highlighting them, that kind of stuff. You can do that on your test always, or any other worksheets we give you. So 220 would be delta y. The v sub x is 7.2. So what is the range? So the range is delta x, right? The rock travels when it hits the ground. Now in order to solve for delta x equals v sub x times t. we actually don't have time. Okay, so that is the thing we're going to solve for first. So we're going to solve for time, and if we have a height, we could always use the equation to solve for delta y. And that equation is delta y equals 1/2 gt squared. By the way, like I said, if anytime you want to stop and try one of these problems before we go over it, feel free to do that. All right, so we have 220 equals 1/2 negative 9.8 times squared. And once again, they're both, and this is in the negative direction, so we go ahead and make that sign -2. So now we do negative 220 divided by negative 4.9, because remember, half of negative 9.8 is negative 4.9. Okay, once we do that, we're going to get an answer of 44.8 equals t squared. So 44.8 equals t squared. And once again, we cannot forget to square root that. It's the common mistake in the past years, okay? So we square root that, and we get an answer of t equals 6.7 seconds. All right, so now we have a time. So that would be added to our givens. And now we're ready to use the other equation that we were looking at to actually solve the problem. So delta x equals, we said v sub x, as we have that up here. So 7.2 times the time we just found. Okay, so we have 7.2 times 6.7. We get a delta x of 48.24 meters. So now we know how far it's traveled horizontal distance. Like I said, this is an example of a two-step problem. We're going to have two-step problems in our class because the state is also going to have them. So here's just an example of how to go through that and work it. Anytime you go through a problem, that's why it's so important to have the givens, and then we realize what we're missing, all right, because we knew we want to use this equation right here, all right, but if we don't have all the information, that means we need to solve for something. So always slow down and use that process so you don't miss a problem that you know the answer to. All right, have a good day.